Okay, let's deal with logarithms. Sorry, let's deal with exponential inverses. So when it comes to exponential inverses, I just want to remind you that an exponent has a base, which is a big number. And for our case, we're going to have x as the exponent, whereas this whole thing is going to be equal to y. That makes it a function. So b to the x is an exponent, but b to the x equals y, or f of x, that's going to be a function. Now, a couple of things that you need to realize about this exponential equation is that b can be a couple of numbers, okay? So b could be greater than 1. That would give you a graph that looks like this, okay? This point here is point x is 0, y is 1. Doesn't matter if b is 10, if b is 20, d is 50, it doesn't matter. B could be in between 1 and 0, in other words, a fraction or a decimal. In this instance, your graph will look like this. And again, this point is going to be 0.01. Now, what I'm saying with regards to this pink one, that is in an instance where there's no plus c, it's plus 0, right? There's no translations, okay? So your standard, just alone, bx goes through 1, 0, 1, okay? What about a third scenario where b is negative? If b was less than or equal to 0, your graph is undefined. So this is not allowed. Okay, if we're talking exponential graphs, it must always be positive. It can be a whole number and it can be a fraction or decimal, but it's not allowed to be negative. Okay, that's your first concept. Second concept we want to get to are logarithms. Okay, so a logarithm is going to be a mathematical function that we use to do the inverse of an exponential function. So if you have an exponential function that says y is equal to b to the power of x, your logarithm is going to be as follows. This exponent is going to go to the other side. So x is going to be equal to logarithm. Now let's get our colors right. This b, the big B, becomes a little b, and this y is going to go to the other side. So these two are inverses. Just like plus and minus are inverses, or times and divide are inverses, or 2 and 1 over 2 are inverses of each other, we are now going to say that y equals bx is the inverse of x equals log by. So just for this quick session, let's just do a couple of practice runs. If I gave you 5 squared equals 25, 10 to the power of negative 3 equals 0,001, and p to the power of x equals q, write those real quick as logarithms. You can pause and then restart. Okay, so those are the responses that you got. Now, let's go ahead and do the same thing but in reverse. Let's try these questions. If I gave you log 2, 128 equals 7, negative 2 equals log 3, 1 over 9, and z equals log wk. Again, pause, try them, and then let's see what you got. I actually added highlighters to my color, to my previous answers, just to help you see. Maybe that helps. Okay, so that's the answer that I got over there in terms of your logarithms. Okay, I'm going to write out a couple of rules for logarithms. Okay, no, not too important right now. Let's do the exponential function. Okay, let's go ahead and do this f of x. So if that's the f of x, then the inverse function, y equals 10x, swap, x equals 10 to the y, and now you're stuck. So this is where you're going to do your logarithm, and your logarithm is going to be log 10x equals y. Beautiful. Y is the subject, and now you rewrite it, f minus 1 of x equals log 10x. Okay, now let's sketch this real quickly. I don't have a Cartesian. Let's do it without. Okay, so if we were to sketch this, you would have your xy Cartesian looking like that. And then, now, remember you need to substitute, right? So we can do x, y, and let's do 1, 0, minus 1. See what happens. That'd be interesting. So if x is 1, let's start with 0. 10 to the 0 is 1. 10 to the 1 is 10, and 10 to the minus 1 is 1 over 10. Okay, there's more options available, yeah. So we can do more points. Let's do 2 and minus 2, okay? So 10 squared is 100, and 1 over 100. That means that our intercept will always be 1 if there's no c. And then so 0, 1, 1, 10. So let's make that 1 10. And that's 1. Okay. So our first graph is going to look like this. There, there, and maybe there. Okay. Now let's do our inverse function. Our inverse function is going to be a swapperoo, right? So whatever you had over here for x, you're going to put it for y. So you're going to have 100 to 10, 1, 1, 0, 1 over 10, negative 1, and 1 over 100, negative 2. That would be your inverse function. So let's go ahead and put that in there. I have 1 and 10 over here, and I'm going to have negative 1 here and negative 10 over there. So this graph is going to look like this. I'm going to cut at this point, and I'm going to go through there, and that's going to be my asymptote. Can't touch it. So this is the f minus 1 of x, and this one is the f of x. And then lastly, I want my axis of symmetry, which has to be the line x equals y. Okay, so that is what the function of x, which is 10x, equals or looks like. And the inverse of the function of x, which is logarithm 10x. Okay, so brilliant. That's how you do an inverse of an exponential graph.